the most missed problem on the quizzes that you guys practice is that yellow one right there and then the green one. Okay, so here we go. Let's do them. Okay, for that yellow one right there, it says H is that, it defines H. It says let C be a number that satisfies the mean value theorem. Now, if you want to find a number that satisfies the mean value theorem, what you're looking for is the C that has the tangent line that is parallel to the secant line. And there's different ways I can say this. I could also say where the instantaneous rate of change is equal to the secant or the average rate of change. So here's a graph, okay? And here's a secant line. The secant line crosses 2 points on the graph, and then C would be the point where you get instantaneous rate of change that is equal to the average rate of change. The average rate of change is the slope of the secant line. All right, all that to say, this is what you do. You go H of B minus H of A all over B minus A. And then you go H prime of C. And C is what we're looking for. So you guys know what B and A are, right? Yes. I hope. You guys know what B is?
Yes.
13. B is 13. A is 4. Okay, so these are the end points on your interval. We don't have H prime. We're going to have to find that in order to do this. So that's what I want to do first. I want to find H prime, and then I'll start plugging in stuff. So H prime would equal, let's see, 1/2 3x minus 3 raised to the negative 1/2 times 3. Okay, now the way that happened was I had to use a chain rule. Instead of looking at this with a radical, I looked at it with the 1/2 power. Okay, the 1/2 power is the outside function, and the inside function is 3x minus 3. And so I took the derivative of the 1/2 power first. That's why we have a 1/2 times 3x minus 3. Then I took one away from the 1/2. That's how I got negative 1/2. 3 comes from the derivative of the 3x minus 3. Derivative of 3x minus 3 is 3. Right? Derivative of 3x is 3. The derivative of 3 is 0. So we just have 3. Okay, so there it is. Now I can simplify this. I don't need to. I don't really want to, but I'm going to do it anyways. It would be 3 on top. 2 would be on the bottom. And the square root of 3x minus 3 would be inside of the, would be multiplying to the 2. Okay, so we have h of 13 minus h of 4 all over 13 minus 4 equals 3 over 2, 3c minus 3. Now, I did change the x to the c because it identified the x value to be c. And I want you guys to get used to that. I want you to be used to that the x is c. Okay? All right, so I'm solving for c. What is h of 13? So I got to plug it into here, and I'm going to do this all mental math, okay? 3 times 13 is 39, and if I subtract 3, I get 36. What's the square root of 36? So this is 6. Let's do the 4 now. Plug the 4 into h. 3 times 4 is 12, minus 3 would be 9. Square root of 9 is 3. Okay, so on the top I get 6 minus 3, which is 3. On the bottom I get 9. On the other side I have 3 over 2, square root of 3c minus 3. Okay, because I have a fraction equaling a fraction, I'm going to go ahead and rewrite this ratio, this proportion, to say 3 times 2 square root of 3c minus 3 equals 9 times 3, and I didn't multiply it out on purpose, so I can see that I can divide both sides by 3. And then I'm going to divide both sides by 2 to get square root of 3c minus 3 equals 9 divided by 2. And then I have to square both sides to get rid of the square root. So I get 3c minus 3 equals 81 over 4. You guys still with me? All right, I'm trying to get that c alone. I'm going to add 3 to both sides to get rid of that minus 3. And then this one way I can do it is I can find common denominators on the right side so I can simplify that fraction. This would be a 4 on the bottom, and that top would be a 12. So I have 81 plus 12, which is going to give me 93 over 4. And then I have 3c on this side. I'm going to multiply both sides by 1/3 so I can get rid of this 3. 1/3 times 3 is 1, so I get 1c, which is what my goal was. And then I'm going to cross cancel here. This 3 becomes a 1. This 93 becomes a 3, 1. So I have 31 over 4, which is our answer. Now, if you're trying to graph 31 over 4, then of course you would want a mixed number. 4 goes into 31 7 times because 4 times 7 is 28, and then I'm left over with 3, so it'd be 7 3/4. Or I can write 7.75. All those answers are acceptable. So this, I don't know what this curve looks like. I mean, I have an idea. It's a square root function, and you guys know that square root functions go like this, right? And we can manipulate this with what's happening to the x. This would be the square root of x. But if I wanted to graph 3x minus 3, the square root of that, what you should do is you should look at this as 3 times x minus 3. I'm sorry, x minus 1 inside the square root. So you can see that we're shifting to the right 1. Then we have this 3 multiplying to the x, so that's also going to change something. So it's going to be something like this, okay? But it doesn't matter, but that's just how you visualize it. The c that we were looking for is a 7.75. So this c, 7.75. All right.